Okay, so today we are going to work on graphing and solving inequalities. So here we have x, which is a variable. When you put a letter in for a number, you call it a variable, and it's when it could be multiple things or you're not sure as to what it is. So it says x is less than 7. This is a less than sign. I like to think of it because this side has like less of a height. This side is less than this side. So other sign would be greater than, because this is greater than this side is. So x is less than 7. That means whatever value for x I have, it must be smaller than 7. If we're graphing it, it would look something like this. So I make a number line and I say x is less than 7. A common mistake was say, oh, it must be 6 or lower, but you actually make your mark at 7 and go down, because 6.75 would work, 6.5 would work, 6.1 would work, 6.9999999 would work. So you start it at 7 and go down. This open circle means that you do not include 7, but it's everything just below this. So it's saying at this point doesn't count, but anything under this is what we'd be looking at. Now there are other types of signs as well. So you might have x is greater than or equal to. If you kind of look, it's like that's almost like an equal sign, and then that's the greater than sign, so we're putting them together. It means x is greater than or equal to, 20. So that's saying there's at least going to be 20 people in the class. There's going to be greater than or equal to 20 people in the class. So that means 20 is included. So I have 20, and I'm going to fill the circle in, meaning this point counts. And I'm going up. That's showing whatever value for x must be 20 or more. Includes 20 and goes up. Now I want to get into solving the inequalities, and that would be a case like okay, so I have something plus 7 has to be less than 33. So my goal here is to solve for x. I'm solving to see what possible values for x could work to make this inequality true. Since this is addition, I want to get just x on one side of my inequality. So I'm going to get rid of this plus 7. It's an extra 7. To do that, I subtract 7. 7 minus 7 makes nothing. So I'm going to bring my x down. I'm going to bring my sign down. Then I'm going to subtract 7 over here. 33 minus 7 would be 26. And then I could graph that. I graph it based off of this solution. The values for x are less than 26. So I have 26 here. Open circle, because 26 doesn't count, and I'm going down. Okay, show you what I mean by this. X has to be less than 26. If I put 26 in for x, 26 plus 7 equals 33, I need to be less than 33. So if I put any value in that's under 26, let's say 25 plus 7, that's going to give me 32, and 32 is less than 33. So this is a solution. 25 would be an example of a solution. Inequalities always have more than one correct answer because there's more than one possible thing I could put in for x to get me less than 33. If it's addition, I'm going to use subtraction. If it's subtraction, I'd use addition. I'll do one more example, then we'll be done. So let's say I had 7x is greater than or equal to, we'll say 56. Right? 7 times something has to give me greater than or equal to 56. So again, I want to solve for x. I want to see what are the possible values for x. So I'm going to divide by 7. Divide by 7. My x comes down because 7x divided by 7 would be x. I'm going to keep my sign exactly the same. 56 divided by 7 is 8. So the values for x must be greater than or equal to 8. Graphing it to show the possible solutions. Right, here's 8, and 8 would work, and up. So anything to the right on the number line of 8 would work as possible solutions. This is showing us what are all the possible solutions. So everything this way would work. Proving my point. 7 times 8 gives me 56, and 56 is greater than or equal to 56. It's not bigger, but it is equal to. If I tried 10, 7 times 10 is 70, and 70 is greater than or equal to 56. So anything higher than 8 would work. If I go under 8, let's say 7 times 7, 49. 49 is not greater than, it's actually less than 56. So 7 does not work.